a very interesting and important topic, that is electric flux. Electric flux is a measure of how much the electric field passes through a given surface area is called electric flux, right? Here there is two more definition. One is saying rate of flow of electric field through a surface, or the total number of electric field lines passes through a given area. So if you explain this one briefly, like there is a surface area, black and yellowish color here. So this is the surface. So this is the surface area, and these red lines are the electric field lines, number of field lines, or maybe rate of flow of field lines, of electric field lines. So this is actually representation of E, and this is the area. So by the definition of electric flux, Greek phi equals to electric field times area and cos theta. By the way, the three definition I described, there is nowhere have written or explain the cos theta. I will explain about this cos theta later on of my lecture. So obviously E is the electric field, A is the area of the surface, and phi is the electric flux. So electric flux is electric field times the area. Now we have to find out the maximum or the minimum value of electric flux. Before that, what is actually cos theta? Let's explain right now. So this theta actually the representation of the field lines and the normal of the surface angle. So here we can see this is the surface, and obviously the normal is this one, 90 degree of the surface of the uh, area, and normal will be this one, the black arrow. So here we can see the normal and the electric field lines are in parallel. It means that the value of theta here is 0 degree. Hope you understand here. Now we have to find out the value of maximum flux and the minimum flux. So here maximum flux and the minimum flux. Let's try. So if we consider the value of theta equals to 0 degree, it means that the normal and field lines are parallel. So in that case, phi equals to E of A cos of 0 degree. It means this is EA. So this phi equals to E of A. Now time to find out the value of minimum. So here let's consider theta equals to 90 degree. In that case, phi equals to E times A cos of 90 degree. So we know the value of cos 90 degree, it means 0. So EA times 0. So this phi will be, this phi will be, 0. So this will be the minimum value and this phi will be maximum value. From the figure, the very last one, C, here we can see the normal in the black line, and all the electric field lines are represented by the orange color. So all the field lines and the normal, here the angle is 0 degree. It means they are in parallel. That's why they given maximum flux here. So this is the maximum equation. So here we are going to find out the maximum flux. On the other hand, when theta is equals to 90 degree, it means that the angle between the normal and the electric field lines. So the orange lines are the electric field lines and the normal is black. So they are in 90 degree. So here is 90 degree, as well as this one also 90 degree. All will be the 90 degree. So if it is 90 degree, it means that the flux will be minimum. Now, very first one, figure number A. Here we can see the value. Obviously theta is always greater than 0 degree, or obviously less than 90 degree. It means that the flux will be either 0 or 90 for maximum or minimum. But if in between 0 to 90 degree, what will happen? It means flux will be decreased by angle increased. Angle increased, right? Now, as I told very earlier, that this cos theta actually nowhere within the flux definition, but where it's come from? Actually, this is coming from the definition of electric field. How? Let's try here. If we consider an effective electric field line through a surface, it means that if there is a surface, so it means that there is a surface. Obviously there will be an area, but for that case of electric field, surface area obviously important, but not very important because of the Sanjita Pu. আচ্ছা একটু দাঁড়াও